the image formed by the lens combination given in the figure. Answer 15 centimeter, 30 centimeter. Explanation. For first lens, f1 equals to plus 10 centimeter, u1 equals to minus 30 centimeter. Using lens formula, 1 by v1 minus 1 by u1 equals to 1 by f1. 1 by v1 equals to f1 by f1 plus 1 by u1. v1 equals to plus 15 centimeter. For the first lens, the image is formed at a distance of 15 centimeter from the right of it. This image behaves as an object for the second lens. For second lens, f2 equals to minus 10 centimeter, u2 equals to 15 minus 5, u2 equals to plus 10 centimeter. 1 by v2 equals to 1 by f2 plus 1 by u2. 1 by v2 equals to minus 1 by 10 plus 1 by 10. v2 equals to infinite. The real images is formed by the second lens at an infinite distance. This image will act as an object for the third lens. For third lens, f3 equals to plus 30 centimeter, u3 equals to infinite, 1 by v3 equals to 1 by f3 plus 1 by u3, 1 by v3 equals to 1 by 30 plus 1 by infinite, v3 equals to plus 30 centimeter. So the final image is formed at a distance of 30 centimeter to the right of the third lens. A flask contains argon and chloride in ratio of 2:1 by mass. The temperature of the given mixture is 27 Celsius. The ratio of average kinetic energies of two gases per molecule is 1:1. Explanation. The average translational kinetic energy per molecule of any ideal gas, be it monatomic like argon, diatomic like chlorine, or polyatomic, is always equal to 3 by 2 kBT. It depends only on temperature and is independent of the nature of the gas. Since argon and chlorine both have the same temperature in the flask, the ratio of average kinetic energy per molecule of the two gases is 1:1. Two vectors both are equal in magnitude and have their resultant equal in magnitude of the either. Find the angle between the two vectors. 2 pi by 3. Explanation. A and B have equal magnitude, so the magnitude of resultant of A and B is equal to the magnitude of either of them. The magnitude of resultant A and B is given by where theta is equals to angle between A and B. This magnitude is equal to the magnitude of either of them. Taking square in both the sides. So the required angle between A and B is 2 pi by 3. In which of the following cases will the work done by maximum? The body is moved through a distance as on the ground. Explanation. Work done is given by dot product of force and displacement. W equals to F dot S. Both force and displacement are a vector component and their dot product is scalar quantity and given by F dot S cos theta, where theta is the angle between the force and displacement. As the body is moved along the ground with the same magnitude of displacement and force, and then force having the least angle with horizontal will be the highest work as cos theta is maximum as theta goes towards 0. The power factor of an AC circuit having resistance R and inductance L connected in series and an angular velocity W is R by bracket R plus W by square L square. Explanation: Re- reactance, as the name suggests, measures the opposition offered to the flow of circuit in the current, but it is different for resistance because in resistance the energy is stored in the resistance and returns later to the circuit, and energy is stored continuously lost in the circuit. When potential difference across a conductor is developed and the value of current changes, it is known as inductive resistance. Inductive resistance due to inductor is written as XL equals to 2 pi FL, where 2 pi F equals to work is equals to W is the angular frequency. Therefore, XL equals to WL. Equation 1. XL is the inductive resistance. L is the reactance of the conductor. In series circuits, the impedance is given by substituting value of XL from equation 1. We get Z equals to under root R square plus bracket WL square. Equation 2. The total phase angle of an AC circuit is given by tan theta equals to WL by R. Third equation. The power factor is given by cos theta. Therefore, cos theta equals to 1 by under root 1 plus W square L square by R square. Cos theta equals to 1 by pi 1 by under root R square plus W square L square by R square. Cos theta equals to R under root R square plus W square L square. Cos theta equals to R by R square plus W square L square. The Earth attracts the Moon with a gravitational force of 10 to the power 20 n. Then the Moon attracts the Earth with a gravitational force of 10 to the power 20 n. Explanation: by Newton's third law and Newton's law of universal gravitation, the gravitational force the Earth exerts on the Moon is exactly the same as the force the Moon exerts on the Earth. F force of Earth equals to force of Moon. Therefore, the Moon attracts the Earth with a gravitational force of 10 to the power 20 n. Which curve may represent the speed of the electron in a hydrogen atom as a function of the principal quantum number n? Explanation: the speed of an electron as a function of principal quantum number n is given by V equals to bracket 2.17 into 10 to the power 7 m s to the power minus 1 into z by n, where V is speed of electron, z is atomic number, E is charge on electron, E theta is alpha, theta is permittivity in free space, H is Planck's constant. We can write V proportional to 1 by n, V equals to constant by n. The above equation represents the rectangular hyperbola, that is, it is similar to the general equation of a rectangular hyperbola. The graph between speed and principal quantum number is a rectangular hyperbola represented by graph C. Find the energy equivalent of one atomic mass unit. First is in joules and then in MeV. Using this express the mass defect of it in MeV by c square. Answer 1.449 into 10 to the power 10 J 14905.6 MeV c square. Explanation: 1 AMU is equals to 1.666 into 10 to the power 27 kg. C equals to speed of light, which is equals to 3 into 10 to the power 8 ms equals to mc square. Heat is absorbed by a body, but its temperature does not increase. Which of the following statement explains the phenomenon? Only PE of internal molecular force changes. Explanation: the heat energy necessary to bring about the change of state that does not appear externally is called the latent heat. During the change of state, the energy supplied latent heat breaks up the intermolecular interactions, and only the potential energy stored of these intermolecular force changes, so the temperature remains constant until all the interactions are completely disrupted. For example, during the change of state from ice to water, heat is absorbed but the temperature does not rise.